Welcome back to PC1 for the first AMA of 2025, and we are off to a flying start. Our pioneering Production Centre 1 now has the capability to produce every component for GT50 and HX50 under this very roof, and it feels pregnant with something beautiful. Our composite laminating facility is now sealed, clean and ready to produce composite parts for HX50. From raw materials delivered to goods inwards, these materials are then stored under strict temperature and humidity controls. Each composite ply is then precisely cut on our all-new composite ply cutting machine. Laser alignment is then used to place every ply into the tool accurately every time. Laminated parts then flow seamlessly from the laminating facility into our whole aircraft oven. Each component is precisely cured using our digital cure control system. Components are then demolded and prepped for paint before receiving their final paint finish. The painted airframes are then moved to the final assembly area. With all of the construction now complete, we've cleared the space for all of the structural test rigs and our ground test area. Our Precision Aerospace Casting facility has been online since January, giving us an end-to-end capability to cast all aerospace casting materials, from high-grade structural aluminiums, alloy steels, to, of course, super alloys. We can produce investment patterns using wax injection molding or modern 3D printing. We can produce block and shell molds for all aerospace cast materials. We carry out wax burnout and mold preheating, and air, inert environment and vacuum investment casting. Everything you need to turn raw material into precision cast components for GT50. To meet the demanding GT50 program milestones, we've added this vast Multus combined machine turn centre. Our precision EDM machine is now online and ready to cut cooling slots in turbine blades. We've added a state-of-art micro-machining centre to produce fuel spray nozzles, hydraulic control valves and fuel control valves. Our fully calibrated metrology lab is now actively policing everything we make. Tonight we're going to focus on our key priority of getting the first GT50 engine built and on the test bench. I'll give you a few selected highlights from the Digi-cockpit and around the broader programme before giving you an update on the timelines and our milestones. Let's get started. Let's work our way from the front to the back of the engine, showcasing a range of technical firsts for the GT50 engine itself and the programme. I'll be showing you the very first starter generator successfully running on test. I'll be showing you the first conforming high-speed bearings made here at Hill, along with the very first fully assembled annular combustion system for GT50. I'll show you the first duplex fuel spray nozzles, along with the first single-piece cooled nozzle guide vane, and of course, the first cast, ground and fully inspected turbine blades. We'll showcase a range of cast core structural components out of the engine and of course the GT50 drivetrain and its associated test equipment. Let's start with the starter generator testing. Just before Christmas we painstakingly manufactured, assembled and inspected the very first GT50 starter generator system. Every conceivable detail was inspected and shown to conform to design intent. We've commissioned our high-speed test rig, which enables us to test the starter generator system electrically, mechanically and environmentally. And with the rig fully commissioned and the prototype starter generator in hand, we've now been able to commence a detailed and comprehensive program of testing across a whole range of physical properties of the device. We've started by electrically characterizing the system, allowing us to tune the control algorithms that run on the power management unit. We've also managed to fully statically and dynamically balance the system, complete all of the alignment between the starter generator and the prime mover, and then we've run the starter generator in generator mode all the way up to 40,000 RPM, and we've run the starter generator in motor mode all the way up to GT50 ignition speed. And I have to tell you that the first time we ran the starter gen up to 40,000 RPM, pretty much everybody that's been involved in the design of the starter generator, the electrical team, the mechanical team, were all in here like a bunch of nervous first-time daddies, waiting to see if the thing was going to work, if it was going to hold together. It was a real moment in the program. The power management unit, which in many respects is the difficult bit in all of this that controls and drives the starter generator, has performed faultlessly. We have got some more tests to do on this at slightly higher power, slightly higher temperatures and a range of other operating conditions but we really don't expect any significant issues with this. It's generally performed very, very well. One area where we did have one small problem is the position sensor that's used to tell the PMU where the rotor is relative to the stator. When we mounted the sensors within the starter generator, there was a small position error with one of the sensors that slightly disrupted the waveform that tracks the position of the rotor, and that was enough to send the control algorithms completely haywire. This is what it should look like, and this is what it actually looked like, just due to that tiny little disruption in the triangular waveform that the position sensor gives. We've fixed this now. We've now integrated a new sensor into the starter generator, giving us a much more accurate and higher fidelity source of position data to use in the control algorithms that control the whole electrical operation of the system. This will give us a much better source of position data to allow us to run the starter generator through its full operating and speed range and clear the unit for use starting the GT50 engine. Interestingly, in terms of modifying the starter generator, it actually took us longer to mail order the new encoder than it did to design, manufacture and install the mechanical bits that are made right here at PC1. Vertical integration really does work, even at the development stage. Next, we move on to clearing the starter gen across its full range of operating conditions from both motor and generator mode. Once this is done, we can expand the testing to include the wide range of temperatures and vibration environments that the machine needs to operate in before running the longer-term endurance testing. Once we've satisfied ourselves that both the starter gen and the PMU work from an engineering perspective, we can then expand that to the broader range of tests that are necessary for approval and certification. And here we have the very first production intent high-speed bearing for the GT50 engine. This inner race and this cage form part of the high-speed bearing that sits at the back of the engine and at the input stage to the speed reduction gearbox. And these units will be tested in full on the drivetrain testing that's due to commence at the end of this month. The precision outer race has been ground right here on this machine by us using the processes you've watched us painstakingly develop over the last few years. The super finishing to get the high integrity surface finish is also done by us right here at PC1, even down to the controls necessary to make sure that the machining marks run in the right direction around the raceway to ensure that we retain oil and have a smooth passage for the rolling elements as they roll round. The precision cages that hold the balls within the bearings are machined right here on our 5-axis machines. The dimensional inspections, surface finish inspections and roundness inspections required to make components of this type are all done right here at PC1. We've done the inspections and these bearings meet all of the required tolerances. We also carry out sophisticated harmonic analysis to ensure that the running surface of the bearing is free from surface defects such as lobes due to excessive clamping forces or periodic features due to machine vibration that would cause rough running and poor life. All of the bearing races manufactured by us to date now meet all of the dimensional tolerances, they meet all of the surface finish requirements and super finishing requirements, and all of the roundness and harmonic content is also exactly what it needs to be for long life and high performance in the GT50 engine. All that remains now is to put these on the test rig and test them. Our compressor design has been both aerodynamically and mechanically mature for a number of years now. However, as other areas of the engine evolve and develop, that itself pushes changes back up to the performance requirements for the compressor itself. Over the course of the last month or so, we've subtly refined the design of our compressor to take account of the evolving needs of the engine. We've improved the performance of the compressor, increasing the mass flow slightly, improving the efficiency by a couple of %. We've improved the surge and stall margins, and we've managed the axial loads that are generated by this on the thrust bearings that hold the whole gas generator rotor in place in the engine. We've also optimized the production process to minimize the machining time while reducing the overall tool wear that we encounter while making each and every one of the compressors. And we've developed specialist polishing procedures to squeeze every last little bit of efficiency out of the impeller that we possibly can. Another area of the GT50 engine that has received extensive development attention over the last 18 months or so has been our annular combustor, and this work is now finally starting to bear fruit. The annular combustion system is a complex arrangement of superalloy sheet metal components that provide film cooling to maintain the metal temperatures at acceptable levels and contain the entire combustion process while mixing the air and fuel and then diluting the products of combustion and feeding them smoothly into the turbine. The resulting geometry necessary to do all of these things is extremely complicated, and over the course of the last 18 months or so, you've watched us perfect every element of the manufacturing process to be able to produce these complicated systems. You've watched us laser cut and roll rings to form the inner and outer annulus, laser weld rolled strips into rings and qualify the strength of those welds as delivering parent metal properties. You've watched us develop the tools and processes to form roll the overlapping profiles of the combustor, delivering film cooling over the gas-washed inner surfaces. You've watched us develop specialist equipment to expand form-rolled rings to the correct diameter and roundness for assembly. You've watched us develop the assembly tooling and precision laser welding processes to assemble the unit as one. Then either CNC drill or laser drill the 1,800 cooling holes necessary to balance the flow of compressor delivery air into the combustor to deliver stable, efficient combustion. And only when you've done all of those things can you build the very first GT50 annular combustion system. What I've got in my hands here is the very first annular combustion system for GT50, a culmination of 18 months worth of process development work and design work to deliver a small, lightweight, inexpensive combustion system for our pioneering general aviation turbine engine. What you can see on the back of the unit here is the 12 individual swirler and fuel injection ports that promote a uniform distribution of fuel and combustion products around the annular combustor. When you look on the outside, you can see the 2 ports for the igniter plugs, the primary and secondary dilution holes that provide the key zones in which the combustion reaction takes place, and then the finer cooling holes, the film cooling holes that provide the cooling film of compressor delivery air over the hot gas-washed surfaces of the inside of the combustor itself. Looking inside it, you can see the gooseneck feature that turns the flow back on itself towards the nozzle guide vane and then through the turbine stages, delivering the 500 horsepower that GT50 produces. What we've got here is a 3.5 kilogram annular combustion system manufactured by our vertically integrated manufacturing processes right here at PC1. Although the development of these processes has taken a little while, in reality, with all of the tooling and equipment now in place, we can produce one of these combustors from receiving raw materials to a finished assembled combustor in around 2 days. Our combustion system requires 12 equally spaced fuel injection nozzles mounted on the rear face of the annular combustor. These fuel nozzles are designed to atomize the fuel down to particle sizes of around 20 microns to ensure that the fuel is adequately atomized for ignition, relight, and to allow the fuel to fully burn during the short duration of time it has to complete the process within the engine. This doesn't sound complicated, but the challenge is that a simplex fuel nozzle, a single orifice nozzle, can only turn down its mass flow by around a factor of 50% and still adequately atomize the fuel. This is nowhere near wide enough for the normal operating range of a gas turbine engine. So as a result, we've had to develop dual orifice nozzles where a primary nozzle sits in the middle of the fuel injector that delivers very low fuel rates just for ignition. And then a secondary nozzle is located around the primary that's able to pass much larger volumes of flow to allow the engine to produce higher powers and full power. Now that doesn't sound complicated either in its own right, but when you consider that we have 12 fuel injection nozzles, so each individual fuel nozzle is 1/12 the size of what a single can combustor fuel injection nozzle would be. This makes for an extremely difficult manufacturing undertaking to hit the tolerances and ensure that we can get uniform flow across all of the fuel injection nozzles. This is the very first production intent GT50 fuel nozzle. The primary orifice is just 0.22 millimeters in diameter. The outer body of the nozzle is just 6.4 millimeters in diameter. The inner body just 3.6 millimeters. And the internal fuel delivery channels are just 0.25 millimeters wide and deep. The surface finish required to seal the parts is also extremely fine, making these components incredibly small and incredibly tightly toleranced just to work at all. These factors render it impossible to make these machines on conventional CNC machines, and specialist micro machining machines are required instead. To overcome this, we've been working with Citizen, a specialist manufacturer of micro machining centers, comfortably capable of rapidly and repeatedly inexpensively manufacturing these components in production volumes. This equipment allows both the milled and turned features of the nozzles to be machined quickly from bar-fed rod on a single machine. In production, the cycle time from raw superalloy to finished nozzle for a whole fuel injector is less than 5 minutes. We're currently busily producing the specialist form tools needed to produce the intricate internal and external features of the dual orifice nozzles. Once we've got these form tools in hand, we can quickly produce the very first GT50 dual orifice nozzles ready for testing. These initial nozzles will be tested in the flow lab and then in the combustion test rig to quantify their flow capacity, cone angle, atomization properties and repeatability in production. Our all-new micro machining center will be delivered and installed in April, allowing us to rapidly iterate the nozzle design prior to first engine run. Fuel spray nozzles are one of the few areas of the engine that still rely very heavily on experimental development. Therefore, having the ability to produce these components in-house from a development as well as a production cost control perspective is crucial to hitting GT50's development timelines. Clearly, some of the most difficult components to make in the entire GT50 engine are the turbine blades themselves. There are two types of blades in the engine: stationary blades, or nozzle guide vanes as they're sometimes called, and then the rotating turbine blades that we're more familiar with. The nozzle guide vanes, or the stationary blades, are subject to some of the highest temperatures in the entire engine, being the first component that the gas flow meets when it comes out of the annular combustor. These components require the very highest grades of superalloy materials and can only practically be manufactured by investment casting on account of the closely spaced overlapping blades and the tightly packed platforms on the outer and inner radius of the blades. In order to produce cost-effective turbine blades, we've had to develop an entire end-to-end casting capability right here at PC1. And now it's fully operational and producing components for GT50. Welcome to the Hill Precision Casting facility. Here we cast turbine blades, nozzle guide vanes, engine casings and internal core structural components from a wide variety of high-performance aerospace alloys. The investment casting process involves the following key stages. First, we create a wax pattern using conventional injection molding techniques or modern rapid prototyping. We then create a ceramic mold using either block molding techniques or shell molding from a ceramic slurry. We then burn out the wax pattern from the ceramic mold, leaving a void to fill with molten metal. We then heat the ceramic mold to near the melting point of the metal to be cast. We can then melt the metal, usually under vacuum or inert environment. The superheated molten metal can then be poured again under vacuum to fill the mold. The molten metal is then cooled at the correct rate to freeze and lock in the required crystal structure. Once frozen, the cast part is broken out from the ceramic mold and cleaned. The running system can be removed, the casting inspected, and then subjected to its final heat treatment to obtain the required mechanical properties. Nozzle guide vanes represent a uniquely difficult challenge for casting processes. Not only are the blades extremely closely spaced and overlapping, they're mounted in inner and outer platforms that pin them together, which often contain complex hook features to secure the nozzle guide vane in the engine. On top of this, each individual blade itself is hollow to allow cooling air to pass through the centre of the blade. These voids need to be created with ceramic cores, which must be cast into the mould and then bleached out with an array of very unpleasant chemicals. Since coming online in January, Mark and the team have been developing the plethora of processes necessary to be able to cast these complex parts. And here is the very first GT50 nozzle guide vane cast in the PC1 casting facility. So these inner and outer rings are generally cast oversized and then machined back. You can see each of the blades formed as an integral part of the casting, and in this prototype version of the nozzle guide vane we'll actually EDM the cooling slots into these to avoid the need for cores. In production, the cores will be integrally cast to make the process more efficient and to give us a more refined cooling channel. Another crucial component that we've manufactured for the first time over the last couple of weeks is the cast bearing housing that supports the rear of the gas generator rotor shaft. This crucial component connects the secondary air system, the lubrication system, supports the bearings, the squeeze film damper and the spring bar, and connects the outside world with the core of the GT50 engine. Of course, the most important and probably the most difficult part of making any turbine engine is the manufacture of the high integrity rotating turbine blades. Now we can produce those too. GT50 uses superalloy polycrystalline blades which provide a nice balance between high performance, long life, reliability and cost effectiveness. While the geometry of the turbine blade castings themselves is somewhat simpler than some of the other shapes that we've had to learn how to cast, the integrity that's required and the quality of the castings needed for these components is absolutely second to none. Now we can do that too. We've created our very first GT50 high pressure turbine blades, and here is one of them. In order to ensure that every part of the turbine blade, including the incredibly thin trailing edge, are adequately filled and free from pores and defects, then we've had to develop an advanced feeding and running system to get the molten metal into each of the blade cavities when we cast these blades in batches. Mark and the team have perfected this over the last few weeks and are now able to reliably fill blade molds with high integrity superalloy material. In terms of the next steps to take these blades and get them to the position where we're happy to put them into an engine, the next thing that we have to do is to switch out the rapid prototype patterns for wax injection patterns to get an adequate surface finish from an aerodynamic perspective. We can then characterize the shrinkage of the casting process and correct for that so the parts come out at exactly the size we need. And then we can go on to calibrate the cooling rates and the heat treatment to refine the mechanical properties to exactly what we need for performance in the engine. Sadly, the manufacture of turbine blades doesn't end with a beautifully executed casting. The cast blade gives us our material properties. It allows us to produce the blade in superalloy material, but to be able to connect the blade to the turbine disc, we need a fir tree root. And for the blade to sit accurately next to its neighbours, it must also have the platforms ground to extremely tight tolerances. Essentially, we need to transform this cast blade into this ground blade with the fir tree added, and then we need to grind the platforms and also the blade tips to precise dimensions to fit properly within the engine. These are the very first ground superalloy GT50 turbine blades, manufactured on the actual Makino Viper grinder that will be used for series production and crucially hitting all of the precise tolerances required. Over the past few months, we've been developing the CNC grinding processes that are required to precisely grind our fir tree profile into the cast root of the blades. To do this, we've developed specialist fixtures that allow us to repeatably hold this complex shape in an accurate manner. We've produced specialist diamond dressing wheels to accurately reproduce the fir tree profile onto the consumable grinding media continuously during the grinding process. Then over the past couple of weeks, we've ground the very first production intent GT50 turbine blades precisely to production tolerances. Due to the exceptionally high stresses, the smallest error in the production of the fir tree root can result in catastrophic consequences for the blade and the engine, long after it's built. Therefore, once the blades are cast and ground, they must be measured extremely accurately to ensure that they conform to critical tolerances. Oliver, our head of metrology, has been developing all of the necessary processes and CMM programs to fully inspect both the development and production turbine blades using the latest state-of-the-art inspection equipment and software. It's not only vital that these parts meet the tolerances, but that the manufacturing processes are capable of reliably hitting them to avoid scrap and the associated costs. The processes being developed here will ensure that each and every GT50 turbine blade is manufactured to the highest standards every time. The second major module of the GT50 engine to be prototyped and then tested is the engine drivetrain, the speed reduction gearbox. Mark and his team are busy converting a big pile of these into a big pile of these using fully conforming processes so that all of the components that we make can be used to contribute towards our approvals testing. If we think for 1 minute what that means for just the gears involved in the speed reduction gearbox, then each gear requires a process of approximately 30 different stages to manufacture it. These stages have all been developed previously and include the following basic steps. First, we need to machine the blank form for each of the gears. This blank is then copper plated to mask the layers of the blank that we don't want to carburize. The tooth forms can then be rough machined. The rough machined forms can then be inspected using the CMM. The teeth themselves can then be carburized. The case hardness and depth is then inspected. The copper plating can then be removed. The material can then be hydrogen de-embrittled. The shaft features can be finish turned and then finish ground. The teeth are then finish ground to final form. Another CMM inspection then validates the form of the teeth. We then acid etch and magnetic floor detect the tooth forms to make sure that they're free from defects. The root of the tooth is then shot peened to improve its fatigue strength, and then the resulting gear is washed, oil coated and prepped for stores. So this is the very first forward casing for the GT50 speed reduction gearbox. This is fully inspected, fully machined and ready for assembly and test. These have actually been designed as cast components, but since we made these parts before we got the casting facility online, we've actually used 3D metal printed aluminium as a casting analogy. We'll subsequently swap these parts out for full cast ones made over there in the casting facility before we do the endurance testing, but these will be more than adequate for the basic performance testing, contact patch development and lubrication system testing. The GT50 drivetrain uses 3 concentric shafts, an external lightweight reference shaft, a main rotor drive shaft and a tail rotor drive shaft, all within an aluminium structural tube that connects the rear casing to the forward inlet casing. Here are the first 3 machining prototypes of the drivetrain reference shaft, the main rotor drive shaft and the tail rotor drive shaft. It's not until you pick these things up that you realise just how light they are and just how far you have to go to be able to make components that are light enough to function properly in an aircraft. Even though these things are made of high-grade aerospace steels, they are incredibly light and still maintain a very high level of strength. The way we have to do that is to make them incredibly thin-walled, but the challenge of doing that is that it makes them incredibly difficult to machine. But we've done just that. Given the extremely high speeds that the speed reduction gearbox operates at, the lubrication system has been designed in a very sophisticated manner to ensure that all bearings and gears are properly lubricated and properly cooled. On this table here, we've got a bunch of the components that are going into the speed reduction gearbox to get lubricant to all the places that it needs to go. One example of these parts and the extremes that we have to go to is this long oil spray nozzle here that's designed to lubricate into a centrifugal weir and then through distributed oil parts to lubricate underneath a bearing race. Here's the first prototype of that oil spray nozzle that's going into the speed reduction gearbox for the testing. In addition to the speed reduction gearbox hardware itself, we're now also building the speed reduction gearbox test rig, which allows us to run 2 engine drivetrains back to back to qualify the performance, the contact patches, the lubrication system function, and ultimately the endurance and efficiency of the gearboxes prior to using them on the GT50 engine. We've now got over 80% of the components for the hydraulic system, the lubrication system, the safety guards, the control systems, and the instrumentation in stock and waiting to be assembled. We've also now taken delivery of the large fabrications on which the test rig is built, allowing us to commence the mechanical build of the test equipment, all well ahead of the commencement of testing at the end of Q1. In summary then, we've built the first starter generator and successfully completed the first phase of mechanical, electrical and control system testing. We've validated the in-house designed power management unit hardware on the test rig. We've built the first casings, drive shafts and bearings for the speed reduction gearbox. We've validated the first half of the production gear manufacturing process. We've now completed 80% of the components for the speed reduction gearbox test rig. We've completed the first GT50 annular combustion system. We've completed the design for manufacture on the first production intent fuel injection nozzles, sourced prototype parts for testing and acquired the production equipment for series production of them. The Hill Precision Casting facility is now online and has cast the very first GT50 turbine blades, nozzle guide vanes and bearing housings. We've ground the first fir tree roots for GT50 turbine blades, completed full geometric inspection and cleared all tolerances. GT50 is coming fast and more importantly on budget. And at a time where everybody else's prices are rising dramatically, ours are robustly controlled. Vertical integration works. Let's talk about the digital cockpit. At the end of 2024, we froze the design of the production PFD and got that implemented on flying target hardware. As we entered 2025, we've concentrated solely on implementing the production version of the MFD and then the IPI and freezing those two for implementation on target hardware. Tonight, I'm going to run through some of the last few features to be implemented on the PFD before taking you through some of the newer features of both the MFD and the IPI. Since the last AMA, we've implemented autopilot bugs for altitude, speed and heading, which are now shown in cyan on the relevant instruments. We've bounded the touch zones for all of the key buttons using highlighted bands for ease of reference. We've reordered the radio bar to make the single COM configuration and the frequency listing much more consistent. We've tweaked the position of some of the text fields on the upper data bar to suit the new IPI and the warning displays, all with the same refined, crisp final design of the user interface. In the unlikely event that a caution or warning is triggered in the digital cockpit, the user interface has been designed to provide the pilot with emotionally sensitive annunciations. What this means that in addition to the standard warning light, you'll also get the key information from the POH paraphrased, telling the pilot what's wrong and what to do in simple language. The system still needs to be able to cope with multiple warnings triggered simultaneously without obscuring critical flight information. Therefore, we've implemented a caution advisory system panel below the main alert banner. A pilot can clear the large warning banner, but the CAS messages and annunciator panel lights will remain on until the condition is resolved. A simple, clean and intuitive system providing the best information to inexperienced owner-operators. When the aircraft is being operated with a non-flying passenger in the front left seat, generally the second screen on the left-hand side is used as either infotainment or as a video feed. For a number of months now, we've been investigating the viability of using that real estate on the screen to display a large traffic scope, giving the pilot the best situational awareness. However, after careful consideration, we've come to the conclusion that you are still better off seeing traffic information overlaid on your mapping information to give it better context and to relay the immediate threats through the HSI in the centre of the PFD display. The benefit of doing it this way is it means we've now got complete free rein to develop a completely optimized user interface for non-flying passengers where they can safely control the climate control functions, Bluetooth phone connectivity, Bluetooth streamed music, and all of the camera feeds from the aircraft. The new MFD display features a crisp, clean design, completely synchronized with the primary flight display. A large camera feed window is positioned on the right-hand side of the screen, featuring forward, tail view, rear view, and downward-facing cameras. Expandable menus are available on the right-hand side for phone connectivity and Bluetooth streamed music. At the bottom of the screen, we have a clean menu bar providing fast access to each of the functions controllable by the non-flying passenger, including climate control, music, phone, camera views, and user preferences. The large video feed window allows you to select the front, tail, rear, and downward cameras and maximize any of these camera views to a full screen view. The MFD can be reverted back to a duplicate set of flight instruments. HX50 has been designed from the ground up to be a digitally enabled aircraft, a machine fit for 2025 and beyond. As far as legally practicable, we've designed the whole operating system to be paperless, using cloud-based secure digital record keeping for the aircraft technical and operational logs and the pilot logs. To do this, the digital handshake between the pilot and the aircraft and support crew and the aircraft needs to be seamless and extremely secure. This will be delivered through the Hill app. On power up, the PFD and the MFD will display a brief splash screen before immediately reverting to their flight-ready modes to avoid unnecessary animation or delay. The IPI, on the other hand, will boot up to a login page requesting the pilot's credentials to ensure that they have permission granted to fly the aircraft and then logging all of those flight operations to his account. By default, the login welcome screen remembers the last login and prompts for a PIN number. By entering your PIN, the system activates your saved preferences and logs the flight time to your account. If a different pilot's flying, then the pilot can select Change Pilot. When the Change Pilot page is active, the system will list all recent pilots or give the user an option to add a profile. Adding a profile is done via a connection to the Hill app over the aircraft network that validates the user's credentials on the Hill app against the aircraft. In this way, owners can control who flies their aircraft and ensure that each pilot is qualified, current, medically fit and insured, and that the aircraft and pilot records are completed automatically and accurately. Once logged in, the homepage provides fast access to all key functions. COM1, COM2 radios, the audio panel settings, your barometric settings and the transponder. We can also provide fast access to other system pages such as the autopilot, Bluetooth phone, Bluetooth music, climate controls, screen and camera settings, and broader system settings. When the autopilot is active, the autopilot menu extends and provides fast access to the modes and bug settings. By swiping across either COM1 or COM2, left or right, a pop-up volume slider will appear that allows the COM volume to be quickly adjusted without needing to delve deep into menus. The volume icon brings up the audio panel volume settings. Similarly, if you swipe left or right along the COM1 or COM2 radio bar areas on the PFD, then this too will pop up a volume slider bar that allows you to rapidly and directly control the volume of both COM1 and COM2 radios without delving into any menu structures. we've added a list button to the cyclic stick head, which gives you fast access to listed and stored frequencies in the radio's memory, whether that be nearest, recents, or your synchronized list from the Hill app. Once logged into their unique profile, each user can store their operating preferences for the displays, what's displayed on their screen, the brightness, their default units, their Bluetooth connections, their network connections for people that want to sync more than one iPad at a time, and then the pilot station settings for audio, PFD options, and synchronized lists with the Hill app. They can also configure their electronic flightbook settings, including which third-party navigation app connection they want to use and what the preferences for that application are. In parallel with the user interface application development, the team have been extensively testing the display processor hardware. The display processor must seamlessly combine the user interface application, the background layers, the touch functionality, and all of the video feeds, as well as the communication between devices. It must do so while delivering a smooth user experience at about 60 frames per second and a seamless touch experience. Generally, so far in the testing, we've found that the user experience is great and the hardware keeps up just fine, but there is some scope for improved memory management and improved performance. So the guys are currently optimizing this right now to get the best out of the hardware and give us the largest margin for future capability growth. Once this testing is complete, then the testing can be extended to the integration of the peripheral devices. While the focus of today's update has been very much the GT50 program, we are of course also racing towards a number of major milestones on the HX50 program itself. Here's a few selected highlights from the development of the Gen 2 fuselage. We've developed greatly improved windshield manufacturing processes, replacing this with this, including tinted variants with UV and IR filters for both the rear cabin doors and also the skylight windows. We've taken our tested optical design for the landing and navigation light system and productionized them, massively reducing the parts count, the weight, the cost, and delivering reliable LRUs. The Gen 2 structure features an all-new structural design for the cabin doors, dramatically reducing the weight, improving the stiffness, and featuring an all-new multi-point locking mechanism. The Gen 2 fuselage also features a fully flat floor, eliminating the step at the door threshold and eliminating the vulnerable bond bead. We've also carried out fire testing on the engine firewall and the cowling panels, as well as the fire detection system. We've also optimized the production paint processes, making sure that the carbon panels come out of the mold with primer already applied. And we're currently qualifying all of the composite non-destructive testing processes to enable us to qualify all production fuselages and rotor blades. We've developed a redundant, all-new electric actuator for wheeled undercarriage deployment. And we've dramatically simplified the mechanical implementation of the primary flight controls, including an electrically actuated friction. And in particularly exciting news, our all-new composite rotor blades have dramatically reduced vibration across the operating speed range, but in particular at our high cruise speed. I'm confident in saying that HX50 will be the smoothest helicopter in its class. In terms of key program milestones, both the avionics test and the starter generator were on the test bench by the end of 2024. Our crashworthy seat is scheduled to be running by about April this year, running about a month behind the declared timescale. The drivetrain test and the electrical system test are both on schedule to be running by the end of Q1, as planned. Years of work designing, developing processes and building infrastructure are finally converging to allow us to build the first GT50 engine and the first full HX50. Our pioneering philosophy of end-to-end control of design, manufacturing and support of our products is working, as we're now able to build aerospace-grade products exactly on budget. With the starter generator now on test and the speed reduction gearbox soon to be on test, we've now turned our full attention to getting the remaining turbo machinery components built and on the test bench for the 28th of June. Thank you for your attention, and it's now time for some questions.
Welcome everyone. Welcome again for another update that we just had for about 45 minutes. So much information packed in those 45 minutes. It's incredible to see how development is literally being speed up exponentially. So right now we are at the AMA session, and it's a time for questions and answers from Jason. Yes, as you have seen, actually we have moved to a YouTube format. It's much faster to update the AMA on the web. You can follow it up and check it out immediately. And it's also transparent on the questions. You can post anything you want. Everybody will see it. And this is part of the Hill community culture. Everything is being reported live in a transparent way. So let's go to it. And as we start the Q&A, remember the ones that have not put up questions, you have the opportunity to just throw it in, and we're going to be answering them one by one. So Jason, ready for it?
I am. It's good to see you both again.
Great. Thank you, Jason. And it's going to be a great session for sure, for about an hour, packed of questions as well. So we have the first one from Graham, and he's asking about the 4-axis autopilot. Could you elaborate on the 4-axis autopilot you're developing and explain how much functionality is it possible to build into the system? In other words, just what and how much can or will you be making it in terms of building layers of operation?
Yeah, so the 4-axis autopilot fundamentally gives us the capability to be essentially autonomous in terms of the operation of the aircraft. We'll be developing the 4-axis system in phases, with the first layers of functionality that we reveal being just extensions of what a normal autopilot system would have. So your 2-axis system basically gives you the ability to control heading, altitude or speed. Whereas 4-axis then gives us a yaw damper and directional control in the hover. It also gives us independent ability to control power as well as disk attitude. So we can control altitude and speed at the same time, as well as directional control to fly in trim. What that means in terms of functionality is there'll be a basic hover hold capability, so the machine can hover itself at a fixed distance over the ground in a fixed direction. It means that you can have essentially a full cruise control system in ordinary flight. So the machine can fly a 3D station as well as the ability to follow target powers as well. So there's a bunch of functionalities like that. As we go through development in future years, there's lots of sort of get me home safe modes, the sort of take me back to an airfield mode kind of operation that we will seek to implement. That won't be available from the launch. That will be something that comes subsequently, and there's a bunch of other higher level functionality like that we can add at a later date. But for now, it's very much about you can auto hover, you can control full. You can control all of the aircraft's flight controls simultaneously, and of course you get enhanced safety in auto rotation, so it'll automatically enter auto rotation for you if required and maintain your RPM all the way down.
I'm looking forward to playing around with that, Jace. That's going to be a really good time, I think. There's a lot of amazing functionality there. I think it's going to improve safety dramatically, so I'm looking forward to having the 4-axis.
So there's one other little feature there that's more nuanced, which is essentially the 4-axis system, because it's got control of the pedals as well. It can take out a lot of the cross coupling between the collective and the pedals. So as you bring the collective up, it will automatically compensate and add the appropriate pedal for you. So it just takes out all of the non-linearity of flying a helicopter. The other thing I should say about the architecture of the system is it's a very conventional autopilot, so we've separated the stability augmentation functions from the autopilot functions. So some of the light helicopter autopilots do everything through the flight controls because they're retrofit systems. So your basic stability, you fly a light helicopter on a windy day and you'll see that the cyclic's buzzing around to try and keep a set point. That part of the functionality is done behind the scenes and the flight controls don't move. And then the only adjustments it'll put into the flight controls are to change a state. So to accelerate or to climb or to turn, but to basically keep the thing exactly where you left it, all that's done behind the scenes. So it'll just appear like a machine that's much, much easier to fly.
I just want to ask a follow-up question on that because this came up the other day. Somebody was asking this question about cybersecurity and the helicopter essentially being hijacked externally. So somebody being able to hack into the aircraft while it's flying and then control the aircraft. Is there anything being done on that front? I guess that would be particularly with the autopilot.
Yeah, that's just not possible. All of that stuff is completely sandboxed. So you'd be able to get into an iPad and that sort of thing. But if you wanted to change the route that the autopilot was following, the pilot has to click a confirm box to do that anyway. It can't force information into our flight control computer. And then the flight control computer is very much isolated. It only has one means of communication out and outwards and inwards, which is totally at the pilot's control. Everything that goes in as a change of state is done by the pilot. Nothing else is connected.
Excellent. Great. Our next question is from Tom. He says, what is the plan when manufacturing starts? As we know that the current facility is not big enough to meet the demand that we have for the orders that we have.
Yeah, once we've got the first flight out of the way and those milestones are done, then we'll immediately start the scale up of the assembly facilities for the larger number of machines. So it'll be either a series of additional rented units or one big one, depending on what's available around us. So it's a very simple strategy to scale up to meet the initial and future demands. We're not held up by planning permission. We're not held up by infrastructure build. We'll just take rented space around us. There's a 400,000 square foot unit available right now, 1 mile that way. So it's not a problem.
Good.
All right, the next one is a sales question. I'll answer that one, and right after, a question for you, Jason. So the sales question is, how long do I have to wait if I order the HX50 now? So right now we have, for exactly those numbers, exactly HX50 orders, we have the number of 975 orders, and for the HC50, 389. So that in total is almost 1,400 orders for both aircraft. So that means by ordering now, you can expect your HX50 in about end of 2028. So the sooner you order, the sooner you be in sequence of your own helicopter. So once you make that decision, I advise you to place that order because that will assure you to have the helicopter sooner than later. Now, Darren is asking about doors. Can the doors be removed, Jason?
Yes. So as you open the door, the banana hinges that go into the A and B pillar have got little cotter pins in them that you can pull out, and then the door lifts off just like it would in other helicopters that you're familiar with. The only thing you've got to be careful of is because of our strip lights and central locking, there's a little electrical connector that quick releases as well to disconnect the electrical connections back into the aircraft. But it's as simple as that. And our lovely new lightweight doors are currently weighing about 5.5 kilos, so they're not heavy either.
Okay, very nice. Grant is asking, out of interest, would there be challenges reading the digital cockpit while wearing polarized sunglasses?
No, we've done that. I did test that. I wear polarized sunglasses, so that's okay. It does work with the screen. It's been asked before, I think, by Steve, and I hadn't given it a lot of consideration until that point, but we've tested it subsequently.
Okay.
The level of detail that Jason has put up in the testing phase of everything you can imagine is out of this world. I know I was expecting something like that, Jason, but you saying that you have tested yourself, that says everything. Next one, Vladimir is asking about the financial health of the company. So what are we right now? What's the stage given the stage of development we are and almost getting to production? What is the financial health? What can you talk about that? What do you can say about that, Jason?
Yeah, we're in an incredible position, really. I'm very, very grateful for the overwhelming amount of support that we've had. I mean, one of the benefits of designing a product that so many people want is people keep buying it. And so we're in a position where we have an order book that's rapidly approaching £700 million. The whole company still remains entirely owned by myself. And so we will never run out of money because we have so many options available to us. We currently have large cash reserves, which even if we didn't have a penny through the door, would give us a 2 to 3 year runway without making any cutbacks at all. So we've got more than enough time to clear our next set of development and production milestones. Our contract conditions, as anybody that's involved with the program knows, is all cash flow positive. So the money comes in before we have to build or source anything. So we've genuinely managed to build this business organically because of the demand for the product, the wonderful support we've had from our wonderful customers, and a prudent small businessman running it at the helm as well, and avoiding spending money when we don't need to.
I was actually going to say that, still considering the complexity of the program, it is a lean organization.
Yeah, very
that makes
much
a
so.
huge difference of that cash burn. Yes.
Yeah.
Yeah. Very good. And next question is coming from Elaine. It says, "Good evening from Stafford, so very close to you. And how do you plan to handle emission measuring, monitoring the the GT50 turbine?"
We do exhaust gas measurements here, so the combustion testing that we've shown previously, we've got some exhaust gas analyzers and all of the calibration data for that, for jet fuel and other fuels. So we do all of that directly here at PC1. We've got a new piece of equipment, and I'll have to apologise, I can't remember the name of it off the top of my head. No, I can't, but that's arrived recently as well, ready for the next wave of combustion tests, and then the gas gen and power turbine testing. So that's all done here.
Okay.
All right, the next one is, "I am a private pilot qualified on Robinson 44. How will be the type qualification for the HS50? Where, with who, and can you elaborate on that process of being ready for piloting this incredible helicopter?"
So it depends very much where you are in the queue. If you're one of the fortunate people that joined this journey early, then you're more than likely to be qualified by us directly at our production facility or our flight ops base here in the middle of the UK. And that's purely because once we get enough of the aircraft into service, we've then got to train instructors and examiners from around the world to support it. But do that while we're qualifying our early owners to fly the machine. The easiest way to do that is just to bring everybody here to the factory as part of an integrated course. So the early adopters, the early owners, will be taught by our test pilots and our company pilots here at the factory, which will be a fabulous experience. And then if you're further down the queue, as the support infrastructure for the type and the company grows, you'll be able to do your type exams in your local territory with your own trusted instructors. And by purchasing an aircraft, you also purchase the maintenance training course and the type rating course with us, whether that's for yourself or an instructor or yourself, your mechanic. So early ones will be with us, and then it will grow out into being supported locally.
Good. And Jason's asking, will there be generator redundancies in the event of a stator, regulator, etc. failure? Dual stator, backup generators, etc. I'm not sure if he's talking about stators or starters, but I'll let you look at that.
Yeah, so the architecture of the starter generator itself is quite intelligent in that the windings are separate, so you'd have to have multiple failures for the starter generator to stop working altogether. At the moment, the power management unit that we've been testing is a single channel power management unit, but it's not terribly expensive and it's not terribly difficult, so if we felt we needed more redundancy in there, we could do it within that device. But of course, like any aircraft, the certification requirements require us to carry a battery that's capable of doing 3 engine starts, so 2 failed starts and then a proper start, and then still having enough charge left to be able to run all critical systems for 30 minutes. And so the main strategy to electrical backup is that you've got that much onboard electrical storage in the battery that if the generator failed, you've still got what would amount to probably, well, certainly over half an hour, but it depends on how difficult it was to start the engine, I guess, on what that total amount is. But it's redundant in that respect. And then the electrical architecture itself, the buzzes and the wiring and everything else that goes around there is all sufficiently segregated so that no single fault can take out both sides of the equation.
Okay.
Noel Sharp. Hi, Noel. Great to see you.
I know.
His question is, what was the reason for rejecting a sensorless motor?
A sensorless motor
That's the
in
question.
what's in terms of the starter generator. The starter generator is very much just about the power density and a really well understood architecture that we can engineer reliably with the highest power to weight ratio that we can. So that was basically the decision that was made a long time ago, and we've just been down that development route ever since.
Okay. Visser is asking, that clean facility is definitely confidence inspiring. I see some smaller vibration testing equipment. Are there any plans to do full up vibration testing on assemblies or the entire aircraft?
Yes, definitely. So the entire aircraft will require extensive vibration testing to get the natural frequencies and the mode shapes tuned exactly where we want them to deliver this smooth characteristic that I keep referring to. So there's a lot of vibration work going to go into the whole aircraft. And yeah, sub-assemblies, there's two different types of vibration testing that we're concerned with. So vibration testing, which is about the general perceived levels of vibration, comfort, and just managing vibration across the aircraft structure as a whole. But then there's also the integrity testing that we do on small items of equipment and units that are going to be mounted on the aircraft to make sure that they can survive in the sort of vibratory environment of a helicopter, and those are all things that are mandated by the certification testing, the environmental testing for that. So yes, we'll be doing all of that for all of the key systems.
Henrik is asking, how is the permit and certification process going? And also versus the authorities developing according to the plan.
That's actually going really, really well. Believe it or not, I've spent most of the afternoon with the head of the GA unit from the CAA who dropped in to see us. So the position is still the same. We couldn't ask for a more supportive domestic authority. We're receiving everything we could have possibly hoped for from them. They're behaving wonderfully towards us. So yeah, the approvals are going according to plan as they stand at the moment. The emphasis is still very much on us. We need to get our testing done. We need to get we need to get all of the systems stable on the test bench so that we can then execute a very clean journey through the extensive certification approvals process that you need to go to. So it's all on us at the moment. We are not being held up by any of the authorities.
Okay, very good. And we've got a couple questions. I'll just answer this one, asking about the simulator, the flight simulator, and how the progress on that is going. So it's going well. We are working on that, and we're looking at about Q3 of this year to be able to release Flight Simulator for both X-Plane and Microsoft Flight Simulator. So that's something we can definitely look forward to as well. And then we got another question about, it says, Jason mentioned there might be an option for a different door design on one side of the airframe to allow for something like a stretcher. Is there any progress on that? I think you maybe mentioned something last time. I'm not sure.
I think that was something a couple of AMAs ago. It's something. Yeah, we haven't done anything with that, is the simple answer. No, we haven't looked at that. At the moment, we're really, really focused on the short-term minimum viable product and getting that onto the test bench, proven, and then we can build from there. There's a lot of work going into the Gen 2 fuselage at the moment, so I can perhaps comment a bit more on that in another 3 months or so. But right now, everything is about getting these big chunks, these big blocks of the aircraft built and tested. So no, that's something that will come later.
Yeah.
What is the typical weight for a nanonuclear combustor? Is it 3.5 kilograms light for the horsepower output? That's exactly how the question was written.
The simple answer to that is yes. A lot of the it's not a straightforward question because an annular combustor isn't just an annular combustor. There's lots of different types. So our annular combustor uses dual orifice spray nozzles. Some of the other ones in equivalent engines use vaporization nozzles, vaporization tubes. Some of the other engines in this power class that are used on twin engine aircraft are designed to run at much higher temperatures than ours and require ceramic coatings and lots of other things. So it's not a straightforward answer. Ours is a relatively old technology, a mature technology. So it's relatively light compared to other ones you might find in other engines. But it's not as high technology as some of those either. So I'm not claiming victory in any way there. The engine, as it stands at the moment, is hitting its weight targets, and that's all that really matters from the point of view of the aircraft performance. Make it work and make it light enough, and we have.
Okay, very good. Louise is asking, do sensors in the turbine have redundancy and automatic error detection and correction?
Yes, they do. All of the sensors that are fed into the engine control system are completely redundant, and the FADEC system architecture has inbuilt error checking and sense checking. So each channel has inbuilt sense checking against what it's expecting to see, and then the two channels will look at each other and check against each other as well. So it's a completely redundant system.
Good.
Next one, will engine water ingestion testing be completed within the PC1 facility?
Probably. We'll try and do as much as we can here yet. It's not, that specific test isn't a test I've given a lot of consideration to at the moment. There's still a reasonable amount of development to be done on the test plan and some of the testing apparatus at the moment. All of the effort of the team is going into getting that first engine through the production processes and getting a conforming engine on the bench. So some of the other testing that comes a little bit later on in the certification program has yet to be detailed. So we'll take a view as to whether it's more convenient to do it here or at a test house.
Yeah. And Rob's asking a good question that I think has been answered in the past, but it's always a fun one to ask again. So, Jason, what is the rationale behind developing not only one massive engineering challenge, which is the helicopter from scratch, but another equally daunting prospect in a brand new jet engine? I struggle to understand.
I just didn't think it'd take me long enough to do the helicopter on its own, so I thought I'd do the engine as well. No, the real reason for it wasn't a choice. So when I set out to develop the helicopter that I wanted, I'd got a very pragmatic engineer's head on about my approach to the program, and I really did just want to take an engine off the shelf. But if you look at the conventional piston engines, they don't go up to a high enough power, they're not refined enough, they don't have the TBOs that you want. If you look at the existing turbine engines, there's some that meet our requirements very closely, but they're outrageously expensive, and the support of them is even more expensive. So I was never going to be able to develop the aircraft that the market needed if I was to take that as a constraint. And I'd been involved in turbo machinery in various forms over the years, and I knew that a sort of low technology engine like GT50 wasn't that difficult in relative terms to develop, and I also knew that they didn't need to be expensive to manufacture. I was very cognizant that it's a huge engineering undertaking to be able to do it, but I got to the point where I just rationalized to myself that there was no way we were ever going to be able to deliver this unless we did it all. It was a classic case of go big or go home. And so we started some work in earnest, and we did some initial feasibility work to prove we could hit the performance. We did some initial manufacturing feasibility work to prove we could make the parts at the prices that we needed to. And then once we'd done that, the difference that it makes to be able to design exactly the engine you need rather than accept one that's a close approximation to it, to the overall performance of the aircraft, is profound. And so at that point it kind of became a no-brainer. If you want the performance and the refinement, and you also want a turbine helicopter for around £500,000, you've got no choice but to do the engine yourself. And so that's what we did. And I think when we look back on the program and what's what this program seeded in the future, you'll find that GT50 will have been the masterstroke in all of it, a bold move to have made, but it'll be the move that allows us to jump straight onto other aircraft, other types of aircraft, and all sorts of other opportunities as well. And it will be the thing that allowed us to crack GA wide open again and give people something that they really wanted to buy. So for me, it was a no-brainer, and it's a fascinating thing to engineer as well. They're wonderful machines. So everybody that's been involved in the programs had a great time engineering it. You know, so yeah, that's the rationale really.
Good.
Very clear. Jason, a simple and direct question. And this is one that pops up frequently, actually, in the presentations as well, more and more. Is there an opportunity to invest in Hill Helicopter Company?
No, not at the moment. Like I said earlier, we're in a wonderful position financially. We're very strong, and so we're just going to keep doing the engineering, get these milestones out of the way, and get the aircraft into the air, and then we'll move from there. We're good, but thank you very much.
Okay, very good. I guess the way to do your own investment in a small portion would be to order an aircraft, and that's an indirect investment in the company.
Yeah, that's the best kind of investment you can make in any business, right? If you want to support us, buy the product.
Yes, exactly. James is asking, are you not worried about the dust and dirt that's being created in the manufacturing plant?
Not really, no. So in terms of the plant here, it's transitioning slowly from being a building site to a fully functioning manufacturing facility. And you'll notice, you can't see in this shot, but you will have seen in some of the shots that we showed as we did the walk around the facility, every specific function has its own enclosure. So all of the activities like the trim shop, they have dust-tight cells with extraction within the dust-tight cell that's the whole building. All of the individual cells are closed off with dust-tight doors. And so every area is controlled in the way it needs to be. And then obviously the laminating room is a clean room. And all of the building work and so on is finished in there. So they're just setting that up now, ready for the Gen 2 fuselage. We're constantly on top of keeping the floors and the place clean. So no, I'm not worried about that. It's something that has to be actively managed. But I think you'll have to go quite a long way to find a factory as clean as well presented as ours.
I can definitely say that.
Come and visit, right?
Yeah, come and see for yourself.
Yeah.
Come and visit yourself.
Yeah,
we serve
by the way,
canapes off the floor.
We have factory tours. We've been these factory tours for a long time. It's an open door on Wednesdays, Wednesday mornings. So if you want to enjoy a very nice tour, contact us. There's a process for that. You have to register, and you can come and visit. Next one from Jeff Johnson. He's asking, is it safe to say that safety, efficiency, and ergonomics are the priorities that we as consumers must patiently wait?
I'm not sure I fully understand the question, but I'll try and answer. In terms of priorities, for any aircraft company, the highest priority is safety. And our approach to safety has always been holistic. So start by designing a machine that's appropriate for the kinds of people that are going to end up flying it. So a machine that's got a high inertia rotor system, lots of power, crash-worthy cabin and seats, a low workload because of the digi-cockpit and the autopilot, and then the active safety management system that will deploy through the flight video recorders, data recorders, and the app-based gamification of how you fly. So that's our priority, and then safety emanates throughout everything we do here at the factory as well. The quality of the materials that we buy as raw material, the design, the quality of the manufacturing processes. Now, all of that does take time, and nobody's having a helicopter from us until I'm satisfied that it's good enough for me to put my wife and my family and take them flying, and to give everybody else that's supported us for all these years a machine. So if the question's about safety, we've done everything we can to design a safe aircraft. And if the question's about how long does it take to make a safe aircraft, well, it takes as long as it takes to get it to the point where it works properly and you've proven it. And that's the approach that we will take if we encounter any problems while we're going through testing and approval. Nobody's having one of these until I'm satisfied that they're good enough.
And just to expand on that, the next question is kind of asking a similar type question, and it's also expanding on, is the autopilot fitted as standard?
The 2-axis autopilot is fitted as standard, so that makes the aircraft stable. You get all of the haptics as standard, so the things that are going to give you your haptic power manager, the things that are going to give you a little push and a pull on the cyclic if you're exceeding flight envelope limitations or excessive pitch and bank angles or rates, all those sorts of things are standard. If you want the 4-axis functionality, so the 3rd axis that will work the pedals for you, the 4th axis that will work the collective for you, and the higher modes that allows you to do, that's an optional error. But I think I'm on record right from the get-go of saying of all the things that you might want to add to this already very well-equipped helicopter, the 4-axis is the one to go for because it gives you so much more scope for future growth capability once you've got those actuators on the flight controls.
By the way, the upgrade for 4-axis would be relatively simple. Right? It's going to be equipped with the hardware that will enable that upgrade, correct?
Yeah. The only thing I can't speak to there, Ruben, is as we go forward in the future and start looking at more extensive capability, there might be some additional sensors and things like that you have to augment the system with. But in terms of the actuation components and the brain, that's all already there.
Okay, next one is a general important question. You have addressed that at the end of the update, but I think this one is more broad. Please address the project status in terms of schedule timeline.
Yeah, so as we stand at the moment, everything is on time for what we declared back in October. So by the end of Q1, so by the end of March, we expect to have the electrical system built in the avionics lab on test. So we can verify all of that. We've already got the starter generator on test and are working through the test program with that. The one point that I mentioned about the crash-worthy seat, we're just taking the opportunity to refine a couple of details with the way we trim the seat. So we've got the energy absorption stuff done, we've got the structural stuff done, the carbon bucket, all the stuff that you usually see in a crash-worthy seat is there and mature. But if you look at our seats in the fuselage, they need to feel like an automotive seat. They need to be able to be trimmed like an automotive seat. And when we did the final design review of the seat before progressing to tooling to produce that, I wasn't quite satisfied that the fit and finish was going to be good enough. So we've just taken a little bit of time to go around that loop and just improve that a little bit before I release it. And that's another example really of what you can expect from me throughout this development program. If it doesn't live up to what I've promised, we're going to just hold it back until it does, because everybody's going to get what I've promised to deliver. And then the other areas, I'm desperately trying to for after March. So yeah, the gas generator. The engine testing in general, that's all on schedule as we stand at the moment. You have to be aware, as we've said all along, that there's 100,000 variables in that we're managing simultaneously. But as we stand here today, I'm satisfied with the progress we're making. I'm satisfied that we're on track. Turbine blade casting has gone better than we expected. I expected it to be much more problematic than it has done. So we've won some time there. The ground fir trees have come out better than expected. The fir tree female roots are better than expected. All of those things are going very well. We've just added to our machining capability to make sure we can push the volume of components through production that we need to fast enough. So yeah, as it stands at the moment, I'm happy with where we are in terms of the engine timelines. The undercarriage timelines are in a good position as well. So as we get into Q2, I expect to be able to test wheeled undercarriage and skid undercarriage over here in the structural test area that I pointed out in the video. So we'll build the test rigs to do the drop testing for those. And then as we get later into the year, we pivot our focus a little bit back to the aircraft once the engine's on endurance testing. And we're on track for all of that at the moment. We'll keep a watching brief. We'll give honest feedback and updates as we go through the year. But as we stand at the moment, I'm satisfied with where we are, that we'll hit everything except the crashworthy seat. The crashworthy seat's not on the critical path. We don't need that until the end of the year.
Exactly. Yeah. Good. Yeah, because it's not linear, meaning it's not stacked onto other things. Not holding.
I'll do the first flight in a deck chair if I have to.
All right. Vesser is asking about machining the turbine blades appears to be a potential bottleneck in the production. Are there plans to scale up the CNC inventory once general production begins?
It's absolutely not a bottleneck. There's very little machining on a turbine blade. The only machining operations that you've got, so that cast form comes out, and once we're using wax patterns, the surface finish on the blade itself will be close to perfect. It will be close to what you can put directly into an engine. And then the only machining is the grinding operations, and that grinder can cope with that. One of those grinders will do 500 machines, 500 engines worth of blades a year. And then we can add the second one just ahead of year 2 to ramp up to 1,000 a year. So turbine blades are really not a problem. And the casting cycle that we showed you in the video, the actual casting process, it's only in the furnace for minutes, and we cast at least one engine set per tree. So we've got huge capability to cast production volumes of blades and nozzle guide vanes. The industrious part of it is actually making the molds, the shells. So that side of it, where we're doing that by hand at the moment, that'll be automated, and that just becomes a robot dipping process. And there's a company about 15 miles that way that makes all of that stuff. So we can just helicopter that stuff into the factory once we've finalised all of those processes and proven they're exactly what they want. So that'll be something that goes into PC2.
Mike Bishop is asking about vertical integration, and more of a philosophical or strategic question here. If all the components are made in-house, does that just exponentially increase the completion and safety risk?
Absolutely not on both counts. So let me give you this as an example. I actually took this little bit out of the video tonight because it was getting a bit long. If you take gear production as an example, right, there's 30 processes in gear production, and a lot of the kit in making gears is quite expensive, and you've got to have the right volumes to justify it. So we have, but at the moment, we don't want to buy that equipment until the moment we go into production, because it's turnkey stuff. You turn up, you put your tools on it, and it will make your gears. That's all these companies do. But at the moment, we haven't bought that equipment. We'll buy that just in time for the start of equipment. So we're dependent for a number of those processes on the subcontract supply chain. And that's transformed our gear manufacturing process from what would have been less than 3 days to go from raw material to a finished gear, when I can do that here, to something that's averaging around 20 weeks at the moment. And Mark is literally pulling his hair out, chasing various subcontractors up and down the country to get our batches of product out when they say they're going to do them, so you can then drop it on the next one. It's a total nightmare. So using a distributed supply chain is very, very, very difficult unless you happen to be Mr. Ford and you say, I want 2 million of those a month, and then you're very important, and so they'll move heaven and earth to do your bits. When you only want a handful of these things, you're never important to anybody. And so quite reasonably, these people in the supply chain are not being unreasonable, they're just managing their own priorities. So it's really difficult to get anything out of a distributed supply chain. That's where general aviation has really suffered, particularly since COVID, where the whole thing was shut down and disrupted, and now they can't bring it back to life again. And then in terms of quality, then, you know, the design is owned by us, whether it's made by us or made by somebody else. All of the processes that are used by the subcontractors are owned by us and set by us. So they're only executing exactly what we've told them to do on machines that we could very well buy ourselves. So it doesn't affect the quality. It does mean that it's a monumental exercise in industrialization and manufacturing, which is a huge job. Please don't in any way think I'm downplaying that. It's a huge job. But in terms of timescales, in terms of cost, and in terms of quality and risk, we are much better off doing it in-house than using an external supply chain. Absolutely, 100%, not a single grain of doubt in my mind, and everything we've done so far has proven me right.
Very good. I think Elon would agree with you as well. Very nice. Let's go to Jim's question, and it's basically a confidence question. So what are the key hurdles needed going forward, and are there any major risks to the schedule?
In very simple terms, the biggest risk to the schedule is uncertainty, right? You don't know how these things are going to work until you put them on test. And then when you put them on test and they have a bit of nuanced behavior, or they haven't worked the way you want to, only then can you work out what you've got to do and respond. And we've got literally a couple of thousand components coming together for the first time that we face that uncertainty with, and that's just the nature of new product development. You know, that's the nature of this journey that anybody would face that was doing it. So I don't think there's any, I don't think there's any one thing that I look at that I think, oh, that could be a showstopper for us. No, I don't feel like that about anything. It'll just come down to how long it takes you to get through the number of iterations you need to beat the laws of physics into submission and for it to work the way you want it to. And we've got a lot of very clever and experienced people, and our track record to date is really good. You know, we get these things to work really quickly. We've taken every opportunity we can to prototype things very early in design. So before the design's even finished, Mark and the team have been making them so we can iron out all the production problems, tolerance problems, all the things that would normally beset a first of type product of any description. So we've got ahead of that. But you know, there's nothing really that jumps out at me as, oh, I'm really worried about that. It's just in any development project, there's an amount of uncertainty that you just have to deal with on the fly, and we'll do that as diligently, intelligently, and professionally as we can.
Very clear. Next question is more of a marketing question. I'm going to answer that one, and then have the next one for you, Jason. So next one is, when and where is the next public event for helicopters in the US? So I'm going to clarify that this year we made a very important strategic decision. As Jason said, we are very efficient and also lean team. It's less than 100 people in Helicopters total team that is making this helicopter, and also on the sales and marketing side. So you can imagine every time we go to an event, we have to really think about the benefits of the total endeavor, because that represents probably 20 or 30 people going to be involved, not only at the event, but also going there, preparing everything, coming back, the logistics. And last year we were at HAI, and it was amazing. It was an opportunity to showcase the helicopter that everybody wanted to see. So they was already in the US. This year is the year of making everything happen. So putting everything together. And as Jason stated, at the end of the year, having the target of flying the helicopter. So we didn't see really as much as an importance as it was last year to be in major events. So we are focused on the making things happen this year. That's our priority. Everybody's absolutely concentrated on that single point. And next year, after flying, then we're going to be going back to events. Also to clarify that we have a different approach to the market. We don't need to be in trade shows actually for sales to continue to be successful as they are. We have a totally different approach from other manufacturers. We have an extreme presence in all digital channels. So we really don't depend on being on trade shows. But we do want to be there just to showcase and give the opportunity for people to look at the helicopter. That was done last year. And next year is going to be all about the flying. So that means that next public event in US counted on 2026. Next question, Jason, is would it be nice?
Ruben, why don't you just mention the customer event that's going to be coming up in September as well?
Oh yeah, that's a very good point. So again, we want to make sure that people have the opportunity to, first of all, always check out the helicopter and what is being done, not only the helicopter, but also PC-1. So those are the regular visits. You can come and look at the showroom that you can see back there at the background of Jason. That's one of the helis. You can go and sit on it and have a tour. It's about 2.5 hour tour. It is part of the tour so that you check out the helicopters and spend all your time there and take photos and ask all your questions. That's the permanent, let's say, trade show that we have. And then also with the events. The events are for clients, and these are special events, what we call the Global Meetup and Discovery events, where we've already done 3 of those. Next one coming up is going to be in September, on the 11th of September. And that's going to be an incredible opportunity for all the clients to get together again. It's going to be the engine event. Not only the engine is going to be there, but other things are going to be showcased and good surprises that Jason is preparing for us for that event. So make plans to be present there on the 11th of September. The other one is going to be the flying event. That date is going to be announced later. So again, next question is from, let's see, Luis. Would it be nice to have the option to have a larger font to take advantage of the larger screen real estate?
We're doing that. That's part of the settings pack. So you'll be able to adjust the font size for people that wear glasses and need it. So yeah, that's fine. We're doing that. That's part of the standard fit.
Okay. And to follow up on that, on the DigiCockpit as well, could you support click on the temperature to cycle through outside and inside temperature?
It's not something that we've thought about, but there's no reason why we couldn't do that. We've obviously got internal temperature sensors and an outside air temperature sensor, so we could do that.
Okay.
Can the videos from the cameras be saved on your cell phone or iPad? Ooh, touching the also novelties there on the Phil app, Jason. How will this be achieved? Can it be made simple for guest passengers to take a video with them after the flight?
Yeah, yes, it will. The whole point of those camera feeds is it makes the flight engaging, and you can relive your flight experience, share them on socials. So we're working through the sort of back office, as it were, of the app and how all of that works. At the moment, it's a little bit down the priorities list, but it will be through the app. There's some onboard storage on the helicopter, and then it'll all be offline through the app.
I just want to give a comment that this is another thing that makes HIL unique, because cameras nowadays in helicopters, they're just so simple. When people put the GoPros here and there, and I remember when Misha and I were going around the world, we had all these options in mounts, and it looked so expensive, like it's such a simple thing, but cameras, they're unnecessarily complex in aircraft. And Jason has put up the whole helicopter. He has built the helicopter in a way that you really enjoy the experience, not only during the flight, but before the flight, through the planning, and also after the flight. And it's not that complicated and not that expensive to equip a bunch of video cameras nowadays on the helicopter. So well done for that, and we're going to see a lot of features and experiences going to be enhanced with being a HIL client.
The app and the global community that we're building, and some of the opportunities that will afford all of the client base, will be every bit as valuable to a private owner as the aircraft itself. From my perspective, people don't buy a helicopter, they buy the experience of flying, and that can be so much more than it is today, particularly when you've got a wonderful connected global network of clients that are all enthusiastic about the same thing. So that's very much what our online experience and our global community is going to be all about. So there's much more to come on that, but I've got to focus on this lot first.
Very good. I'm excited about that. There's lots of great things we can do with video, especially with AI coming now. We can do some great things for that experience after the flight as well. So Jason's question is about software issues on a fully integrated system can be extremely complicated to debug. They are irritating on a ground vehicle, but could be very dangerous on an aircraft. How will HIL tackle the testing?
So we've got a very, very simple and very, very robust software architecture. I'm not going to go into extensive details about it, but we've really gone back to basics with how we implement the digital cockpit. And all of the flight critical software is either done bare metal on microcontrollers through FPGAs, and all of the layers of software that can make things complicated have been eliminated. And we have a sort of redundant fallback UI that will present all of the key instruments to you using much lower level graphics. So if anything goes wrong with the fancy stuff, it doesn't matter. It can just be isolated and corrected offline. And then the feature set that we've got in the software, although it looks very Gucci, it's a very, very limited cutback set of features that just does what we need it to do. We're essentially just replacing a set of steam gauges with a slightly more modern take on that. So, and the same with the electronic control, like your FADEC control, it's all microcontroller based, very, very basic. And the same with the flight control computers and things. These are not big sophisticated computers with layers of operating systems and drivers and things. They're very simple systems.
That's very reassuring.
Next one is from...
No, I was just going to say it's very reassuring because you know, the last thing you want is a fancy car, like they said in the question, that, you know, 5 years later just starts bugging like crazy. And this helicopter is supposed to be a legacy helicopter that'll last many, many years. And so, you know, we want to make sure that from that point of view as well, we're not running into electrical issues all the time. Yeah, I like that.
All right, Rowan. Shout out to Rowan in Australia.
Hi, Rowan.
Hope you're keeping up with that kite surfing, Rowan. So he is asking about the heat, a question related to the heat and the environment in Adelaide in Australia. In Adelaide, it gets really hot, regularly 40 to 45 Celsius in the summer. Realistically, will it be able to run aircon on the ground for extended amounts of time using ground power? And what will be the receptacle for that?
That's a very good question. You will be able to run the air conditioning on the ground. The receptacle is essentially it'll be the same one that you use for your ground power. I can't remember the name of the connector now. It's the same one that's used in most aircraft, the heavy duty ground power connector. So you can use that. You obviously won't be able to use a 13 amp domestic socket or anything like that. It's not enough power. So it will be the same port that you use for ground starting the engine. I'll answer that one offline. I'll go and dig out the actual port that we've got specified and send it over to you.
Okay, sounds good. This is just a quick, simple one that I'll answer, and then we'll go on to the next one. The question is about, in addition to a retractable landing gear, a fixed landing gear option might be nice as another option. So if you look on the website, we've been offering fixed skid gear for a long time now, since basically the beginning of the project. And so you can check that out. It's definitely an option for you. The next question is, what if I forget my phone? No phone, no flight?
No, if you're if there's a saved profile in the aircraft, you'll be able to use your PIN number to get in, because there's lots of scenarios like that. Phone goes dead, lost the phone, dropped the phone out the window. There's lots of things where you wouldn't want the machine to cut you out or isolate you. So we've got that covered. We're being quite sensible about that.
Excellent.
All right, Manuel has a short and very important question. What about the rotor head? Anything about the rotor head to share?
There's a very exciting update coming on the rotor head, but I'm not ready to share that yet. The rotor head is basically the same formula that it's always been, the same formula that we showed when we showcased the aircraft at Duxford. So conventional strap packs, elastomeric, lag dampers, really neat blade fold mechanism. Nothing new or scary in there, just well proven and well understood. Technology with a modest flapping hinge offset so that you get nice benign but positive handling qualities. All the best things from bygone years.
What is the status of the development on the rotor?
It's mature. We've got one minor change that we're making at the moment that we'll showcase as part of the flying prototypes. But yeah, it's mature at the moment. We've got a little bit more characterization to do on the lag dampers, and Stuart's working through all the flight mechanics work on that just to make sure we get the response and the performance and life of those just right.
Very good. Steve's asking, on the September 11th event, will you be running several GT50s at the same time? So example, one on nominal flight operation profile, one on a crazy abusive pilot operation profile, and one on sustainable fuel.
No.
It's already complicated to have one
yeah.
running inside. You can imagine several turbines running inside PC-1, right?
No,
I love your question.
The event is really a showcase of what we've done for the customers. So we'll have an engine there that's running, but it'll be doing something very benign, because these things run in a bunker on a test. We're going to have hundreds of people here, no, it'll just be dancing around like a pantomime horse on that day. We'll put it back to work the day after.
Very good.
Okay, I think next one is more of a autopilot question, a little detail. Will XC50 have a flight leveling system in case of pilot spatial disorientation?
That's an inherent part of the autopilot system. So the basic functionality of the two-axis autopilot that's carried forwards is you have a stability augmentation function. That's just rate damping. So it'll resist pitch and roll rates to try and keep you the right way up. Then we have an attitude hold function that essentially will always try and hold a fixed attitude that the pilot's commanded. And as part of that, it has the ability to, if you hadn't got attitude hold mode on, when you turn it on, it will naturally turn you to wings level into a sort of benign flight attitude, so you can get yourself together again, and then you can layer the additional modes on top of that. So in that sense, it works exactly the same as all the other conventional helicopter autopilots.
Okay. This is a question from Chris that hasn't really popped up in a while, but you've answered it several times in the past. How is ground resonance addressed on landing? Obviously, we know that three-bladed rotor systems have ground resonance potential issues.
It's dealt with in a number of ways, but basically we've got dampers in the rotor system, and then we've got dampers in the undercarriage to stop the lag motion, the first lag mode from coupling with the rigid body modes of the airframe. So you've got some dampers in there, and we try and tune the stiffnesses and dynamic behavior of the aircraft away from it as much as we can.
Okay. Good.
Okay, and what is your projected lead time? I think there's some things here that have been covered. I'm just gonna read the question to see if we are missing anything. What is your projected lead time production rate in the future once production is up and running? You feel you have enough support from the UK government? You have touched that. Probably we can answer both together there. And government, local, central government on this project.
Okay, so let me, in terms of support from government, we had an Innovate UK grant in the very early days that was transformative for us. It allowed the relatively small engineering company that I had at the time to turn more of its staff and its resources onto the development of the helicopter, it catapulted us from there. All the growth that you see subsequently was off the back of the work we were able to do under that grant. So in that respect, I will always be grateful that we were able to qualify for that grant and the impact it had on us. In terms of the UK Civil Aviation Authority, they've been amazing. You couldn't ask for a more supportive and positive regulator. We've been wonderfully supported there. If you're talking about broader government, anything to do with planning permission has been a total nightmare. So that's caused us major problems in developing the production facility, and we've ended up here at PC1 because we couldn't build what we intended to build in the first place, because we couldn't get a decision on planning fast enough. In terms of engagement with local politicians and ministers and things, we really haven't done a lot with that yet. But again, I think that rests with us. So Peter is actively pursuing those sorts of channels at the moment. But overall, our overwhelming experience has been that we've been very well supported to date. As we go through a rapid growth phase now, I think our needs will change, and we'll need to look to government to make sure that the wheels of the machine turn fast enough. But thus far we've been very well supported.
So very comfortable with these types of rotor systems.
Lovely. Yeah, no, it's very straightforward. The aft part of the mast cowling, there's a split line that allows that to pop open, and the engine cowling removes, so you can climb up onto the top, and you can see up into the rotor head, and you can access pitch links, lag dampers, you can access a swash plate, all of the important stuff, the control linkages, the servos. You've got a much clearer view of everything than you would normally be used to on a lot of aircraft. So although it looks very sealed in like that, when you see how those cowls open in reality, it gives you a perfectly good view. And then we're tweaking the way that you climb up there to put some footholds and things in there to make it much easier to get up there when you're inspecting the machine out on the apron without any ladders or anything. So the donut itself doesn't come off. You look up from the bottom, but you can see everything from the bottom anyway.
Very good.
Steve has another question. A practical, simple question. Where is our current thinking on pockets for handheld radios, POH, maps, etc.? Stuff that we have to store.
I really want to answer that because I've got an amazing answer for that, right? But I can't because I'll out myself on one of the surprises that we've got for you. so
just leave it. Just leave it. It's a surprise.
It's a surprise.
It's being taken care of, and you're gonna love it.
Yeah. So we've got a brilliant answer to that. We've slightly tweaked the shape of the center console at the back. In the original design, the back of the center console leaned forwards a little bit, which made the storage bin under the armrest quite a funny shape. So we've just pulled that back face a little bit, so we've got much more space now in the under the armrest for your bottles and things. We've got some mat pockets down the side of the center console as well in the carpeted area, and then we've got a couple of other amazing locations to store things securely for you, but I'm not going to tell you where they are at the moment. You'll have to wait, I'm afraid.
Excellent. Bryce is asking, you mentioned on a prior AMA work being done to mount the engine on an angle and remove the angle gearbox. Have you decided to stay with this original configuration or change that?
No, that's all done. So the bevel box on the front of the engine went a long time ago. The drive shafts now go directly straight out the front of the engine, flexi coupling, and then up into the main rotor gearbox. The engine sits at a 12.5-degree angle on the back of the helicopter, and that simplifies a whole host of stuff. It saves us about 9 kilos on the overall weight of the helicopter. It was a really significant move. The other thing that we've done on the production version of the GT50 is we've got a much better developed inlet, and I'll showcase some of those things on the next AMA. But we've got a much better bell housing going into the inlet for the engine as well, and all of that's been facilitated by that change. All of your oil ports are designed so that they don't bleed oil past the labyrinth seals when the engine's stopped and the engine's sloped and then you're parked on a slope as well. So all of that sort of stuff's been taken into account. It is designed from the ground up for that installation. So it's very much a positive move for the helicopter. I don't see any downsides with it.
Yeah.
Cecile has an interesting question. Hi, Jason. Thank you for sharing your journey, your dream. Have you appointed a test pilot yet? Who is the lucky one?
So we haven't appointed a test pilot yet, though I was talking to the CAA today about who their test pilot's going to be. So we've got a pretty firm idea about the test pilot for the authority, but our in-house one, we haven't appointed him yet. What was the name of the guy that asked the question?
Cecile Berry.
Okay, so there is another couple of guys that have shown interest in doing that have been through the Empire School and the US Navy Test Pilot School and all these great things. So I've got a short list of people that it may well be, but we haven't appointed anyone yet.
Okay, very good. I'm going to go with the last question here in just a second, Jace. Thank you again for taking your time to be with us. I know how busy you are, and so it's always very appreciated update everybody on exactly where we are. And for anybody wanting to attend the next AMA, it's going to be coming up on May 7th. We're going to have dates coming out released for that on emails and so forth. So you'll be updated on that and be getting a link to join the next one as well. And I just want to thank everybody else for taking their time as well to be here and join us. We've had well over 2,000 people joining on this AMA update. So it's always nice to see the interest from people all over the world and the comments and questions and everything that have been coming in. So thanks for taking the time for that. So Jace, I'm going to finish off with this last question. So it's coming from Jake, and I think it talks to the culture of the company as well, the answer that you're going to give, because I know how you're going to answer this one, because it is a question that people have a little bit of maybe trepidation or fear over, because we have a flight recorder system in the helicopter. And so I think the answer is important to talk about the general culture of the company and why we're doing some of the things that we're doing and the way that you're doing them. So it says, will you track all of our flight behavior? Can we opt out of that? If you find a major error or a mistake in flight, do you have the capacity to brick the helicopter or report it to the authorities?
So you've got to remember that we are all intimately tied together in this community that we've built. We need to make reliable helicopters, otherwise the business will collapse. And if you've bought a helicopter from us, you need the helicopter to be reliable and safe, otherwise the value of your helicopter will collapse and you won't be able to resell it. And you also need to enjoy your hobby without putting yourself at undue risk or not being there for your family the next day. So everything that we've done is about making sure that you can continue to enjoy your machine for many years without incident. Now, our active safety management system is very much about a two-way partnership. What we've said to everybody is we will provide the insurance for the aircraft, and we'll do that at rates that are totally unmatched by anybody else in the industry. Now, to do that, what we've got to do is manage the risk for everybody, okay? So we need to make sure that anybody that's exhibiting characteristics that would likely lead them to having an accident at some point in the future, why would you wait to act on that when you can intervene and say, why don't you have a little bit of extra training on this, or why don't you fly with a safety pilot for a bit, or are you even aware that this is a type of behaviour that could lead to a disaster? So it's about us being able to support owners to be as safe as they can possibly be, and in return the helicopter gets a better reputation for being more reliable and not involved in as many incidents, and on top of that you get far more cost-effective insurance as well, because the risk is lower for everybody. We're part underwriting the value of the hull anyway, but then the risk that we're underwriting is lower because we're managing it properly. So this is never meant to feel like a black box on the dashboard of a young driver. This is just meant to feel like having a co-pilot there all the time that's there just watching over you and just helping you be the best version of the pilot you can possibly be. So it's meant to be supportive, and it's meant to be a positive thing, not a negative thing at all. We're not watching over people in terms of looking at exactly what they're doing and where they're going and when and why. We're just parameterizing the flight envelope and looking, is it a VFR helicopter in VFR weather? Is it flying within the normal flight envelope? And parameters like that will help us support people to stay safe while they're using their machines. So it's about positive support, letting people get the best out of the machines that they possibly can, and protecting the reputation of our company, our machines, and the whole idea of flying helicopters, whoever's helicopters you fly, to the greatest extent we can. So I see it as something that's very much for the benefit of everybody. You know, so that's my intent with the system. It's not meant to be Big Brother. It's not a police system. It's not there for the benefit of the authorities. It's there to keep everybody safe and to protect what we've all got invested in these machines and this company.
I love that. And, you know, coming from somebody that's been an instructor for the last 20 years, sitting beside, you know, people, I hope that, you know, as private pilots, you guys have had wonderful experiences with instructors. And, you know, I've seen it, you know, 1,000 times over where our pilots will come back and say, you know, let's go flying and let's just spend a little bit of time. Take me up into the mountains. Let's go do some flying around in the mountains. And I just want to be, you know, give me feedback on how I'm doing. And so I think this is that opportunity. Even if you don't always have that instructor sitting beside you, you have that opportunity to be given feedback if needed. And I think it's going to be a really important thing for generally improving safety across the board. I think that's important.
So let me just add that to something as well. One of our customers has got a one of the modern turboprop aircraft, the sort of 6 or 8 seat, 330 knot, amazing machine. But that manufacturer does something very similar. They gamify the profiles. So he co-owns the machine with one of his friends, and the app scores them on every approach that they make, and they compete with each other as to who can fly the best approach, and then give each other grief about who's ahead in the league tables. And it can be done well like that. It can be made into a fun thing for positively reinforcing the right behaviour as a pilot, and identifying which areas of your flying there's scope for improvement. It's something that's there to be. It's genuinely something that's there to be a good thing. We're not there to police people and make flying miserable. That would be astonishingly self-defeating on our part. It's there just to allow us all to have the most fun while being as safe as we possibly can.
Yeah. Amazing. Thank you again. Everybody, we're excited to see you guys on May 7th for the next AMA that's going to be coming up. And we've got more questions that people want to ask at that time as well. And so we look forward to spending some more time with you, Jason. Thanks again for taking your time. We always appreciate it, and looking forward to seeing you on the next one.
Thanks, everybody. Thanks for your time. Thanks for your questions, and thanks for your support.